Hello everyone, Dr. Ziad Tahir here. This tutorial is about 2D transient heat transfer analysis through FIN in ANSYS Workbench. So that is the end view of a FIN, and it's just a section of that. So that is aluminium fin. Density is 2800 given. Thermal conductivity 170. Specific heat capacity 870. They're used to dissipate heat from the device. The section of the fin is shown in the figure. The fin is initially at 28 degree, and shortly after the device is turned on, the base that temperature is 90. So the temperature of the surrounding air is 28, and corresponding heat transfer coefficient, convective heat transfer coefficient is 30. So that is the problem statement. And required is determine temperature on the tip of the fin, somewhere here on the tip of the fin, and then plot temperature variation from base to fin along the center of the fin. So then temperature distribution is required. So this uh, this problem is a solved example in chapter 9 analysis of two-dimensional heat transfer problems from the book Finite Element Analysis Theory and Application with ANSYS by Saeed Moaveni, 4th edition. So this video tutorial is a part of ANSYS Workbench Thermal Analysis video series. So here 2D steady state heat transfer few uh, analysis. So they are you can watch in that my channel. Okay, so steps to perform that heat transfer analysis through FIN. The first one in ANSYS Workbench, you need to start a transient thermal project, then engineering data, add material, then geometry, create a geometry, and then in the model assign materials to that geometry, and then create a path uh, so that you can plot the results, then mesh. Then in the setup, you need to go for thermal transient and apply initial temperature, then eh, apply temperature boundary condition, then apply convection boundary condition. Then in the analysis setting for that transient analysis, keep that time as 120 seconds. And then the solution need to get uh, thermal temperature for whole body and temperature along the path, then solve and then get results for that temperature along the path. So the first step is to start a project, thermal transient. Here is workbench, and the workbench toolbox, there is an analysis system. So in the analysis system, double click on transient thermal, and that is a transient thermal. And there are steps for that transient thermal. So save this project somewhere in your computer. So I have saved that project as 2D fin in the computer. Next step is in engineering data, need to add material, and for material density, thermal conductivity, and specific heat capacity are required. So in the project, double click on engineering data, and here create a new material, and I'm going to name that as aluminium, and then drag the properties. The first one, drag density to that, then thermal conductivity, isotropic thermal conductivity, and then specific heat capacity. So now you can see that there's a question mark on the aluminium, and you have density here. So density of that material is 2800. Then thermal conductivity is 170, and specific heat capacity is 870. So now these three properties with the units, they are being mentioned here. So the units, but these thermal conductivity and specific heat capacity are in Kelvin. So for heat transfer analysis using conduction and convection, so it doesn't make any difference that if you're using Kelvin for the properties or degree Celsius for the properties, because both heat conduction and convection equation they use delta T, and change in temperature is same in both degree Celsius and Kelvin. So that material once it's defined, so then you can save it. So just so now this material has been saved. So just close that window. So the next step in the geometry analysis type is 2D. So just click on geometry and in the properties, advanced geometry properties from 3D, take it to 2D and then start a new design modeler geometry. And in that design modeler, you need to first sketch. So here, right click on geometry and then new design modeler geometry. So that is design modeler. So I'm going to first sketch that. And here are the values that all the dimensions are in millimeters. So first you need to change units to millimeter for sketching. And then the maximum length is 100 millimeter. So what I'm going to do here, I'm going to XY plane and in XY plane, I'm going to sketch that one. But before that, there are that is modeling and then the sketching. In the sketching, go to the setting and turn on grid in the grid and snap. And the major grid spacing is 10 and the minor I am going to set here as 2. So now I'm going to draw it. I'm going to use that polyline. So let's say starting from that one all the way till there. Okay, so then that way 10 centimeter, then 10 centimeter in that way, then 30 centimeter in that direction. So that is 10 millimeter, then 10 millimeter and 30 millimeter, and that spacing is 25. So then that is 10, 30, and then that is 25, that is 30, 10, 30, then that is 25. Oh, I'm going back, sorry. So that is 25, 30, 10, 30 by reaching here and then close end. Now that is being drawn. So now you can check the dimension. So display value as well. So that one is 10 millimeter. That is 10. So both are 10. Then that is 10, 10, and then this one is 30. That is 25. That is 25. Okay, so now in the setting I can remove that grid. So you can see that sketch is done with all that values accurately drawn. So sketch done, dimension, then go to concept and then generate. So for that one, in the modeling, click on sketch and then in the concept, surfaces from sketches and apply and then click on that surface on here and then generate that and now you can see that so that geometry like that whole part is being generated. Next step is start model and for that one so this one you can save it. So after saving you can close that one and then in here double click on model and it shows here starting mechanical. It will take some time to start. So that is a new model and in that new model so the rest of steps like setup, solution, and results, they are going to perform in that one. So in the model, the first step, you need to go to geometry and assign that material. So for that one, geometry, there is a surface body and material assignment is structural steel. So you need to change it to aluminium. So now for the new material for that surface body is aluminium. Next step in the construction geometry, need to create a path. So that path is required to get the temperature distribution along the center of the fin. So for that model and then the construction geometry path. So that is a path and it asks about that what are the coordinates. So for that one you click on coordinate system. So that is right in the center. So then x-axis there is 0, 0 at the origin. And for that second one, x is 40 millimeter. And now you can see that. So that is a start and that is the end of that path. Now remember that in the home you need to change the units here and units you need to keep that the standard one. So for temperature, it is I'm using that Celsius and then these are the units. So now you can see that there the path is being created. So I am going to rename that as path, let's say path 1. So that is now path 1. While creating path, the number of sampling points is by default it is 47, but here the total length of the path is 40. So I am going to use it one less than that. So that is 39. Next step is to perform mesh by suitable mesh element size. And for that one, need to double click on mesh and the default element size is something given. So I am going to use that 2.5 millimeter as mesh size and rest of that all I'm going to keep that as program control. So in the mesh, so go to mesh here and then generate mesh. So that mesh is being created, which looks quite uniform. Next step in the setup, thermal transient, apply initial temperature and the initial temperature is 28. So here initial temperature and it's a uniform temperature and that is 28. Next step is in the thermal transient by clicking environment temperature and the temperature boundary condition is for the base which is 90 scope geometry edge definition and then the magnitude of that. So that base temperature is 90 and for that one uh, again by clicking on the thermal transient. So either you can insert temperature there or go to environment and then temperature. And the temperature, click on temperature. It's a scoping method geometry selection. So that is edge selection from here. Apply and then the temperature here. The magnitude of that temperature is 90. In this way that temperature is being applied. Next step in the environment, apply convection and the convection heat transfer coefficient and temperature. So for all other edges, temperature is 28 and heat transfer coefficient is 30. So for that one, right click on that, go to environment and then convection. And for that convection, need to select these are the value. Film coefficient is 30 and the temperature is 28. And then geometry selection, you need to perform that geometry selection and it's very simple. Just click the mouse and then just move that on the edges which you need to select. Okay, so all edges you can see they are green. So then apply. So there are 15 edges. So 15 edges selected. Now you can see that both boundary conditions are applied. Next step is in an analysis setting, number of steps equal to 120. So here in the thermal transient analysis setting and Then number of steps, I'm going to use that 120 seconds for that. Okay. And then rest, I'm going to leave as it is. So now analysis setting initial temperature. So all these properties in the transient thermal, they are being applied. Next step in the solution setting, need to apply thermal temperature for the whole of that body and then thermal temperature along that path, and for that one scoping method path and path name are required. So for that one, in the solution, click on the solution and in the thermal temperature, so that temperature for whole of the body. Otherwise you can go here, insert thermal temperature, and this temperature too I am going to rename that temperature along the path. And for the scoping method is path, and then here is the path one. So now in the solution, that solution, whatever are the required parameters, so they are done, like the temperature along that path, and obviously that path, end of the path is at the tip of the node. So whatever is the temperature here, so that is being computed. The next step is to solve, and it is very simple. So just click on the solution and then solve, and it will take some time to get the results. So you can see that is a 1% here, 2%. Now the solution is done, and now the solution is done. So you can see green tick on solution, temperature, and then temperature path. Next step in the results, so you need to get temperature and then temperature about that path. So for that purpose, here you have temperature. So So that is the temperature distribution. At the base, it is 90, and then that is somewhere like not 87, but something which is on that. And for that one, on the tip of that, you can use that probe for that. And the temperature at the tip is somewhere 87.066. Okay, so now that is time, and that is the temperature, and then 120 seconds for this one is quite a good time, because the final results here, the maximum is 90 and the minimum is 88.23, and it is well converged, as you can see, 88.23. So that is about at 83 seconds, or even that 88.23. So like it start converging somewhere like 60. So like somewhere here it start converging. But anyway, 120 seconds for this type of analysis is quite good. And then the temperature along the path. So for that path, temperature along that path. So that is the temperature along the path, and then that is a 90. And as it's moving on, so the temperature is going to decrease, and that is temperature along that path with a step size of uh, 1 millimeter. So it can be copied from here and then exported. So this is all about transient heat transfer analysis through that fin. Now finally, summary of the analysis. The first one, you need to start thermal transient project in Workbench and then add material in the engineering data. And for transient analysis, the three properties are required. Then start analysis, so sketch and then generate surface from that, and then assign material in the geometry, and then create a path, then apply mesh, and then apply boundary condition. The initial temperature is 28, then temperature of the base, which is temperature of the base, which is 90. Then all sides other than the base, they are exposed to air. So then temperature and temperature and convectivity transfer coefficient both are required, and for this one I said that 120 second, but it's not necessary that the solution will converge for 120 second for all the problems. So it depends upon the problem that it is going to converge. Then the solution, thermal temperature is required and temperature along the path is required, then solve, and then you'll get results, and the results temperature about that path is required. So this is all about this video tutorial. Thank you very much for watching. I hope you like this video. You can leave comments for your feedback.